All right, class, welcome to the topics for Module 8. So I'm going to do some examples and show you how to do goodness of fit tests and one-way ANOVA in StatCrunch so that you can continue to avoid having to use these formulas, and you can just do it all using the software. The first thing is, given some sort of probability distribution, finding an expected frequency distribution. Essentially, all we're doing is we're taking this. So we have in this situation we're describing some probability distribution. The value can be 1, 2, 3, or 4, and the associated probabilities are 0.16, 0.37, 0.61, and 0.31. If you can picture in your mind a four-sided die that's weighted in an unfair way, that's what this is representing. So we want to roll this die 722 times, and I want to ask, what do I expect to get out of this? Like, how many times would I expect 1 to come up? How many times would I expect 2 to come up, and so forth? Simply put, I would expect 16% of my 722 rolls to be a 1, right? So it's just 722 times a 0.16. That's all we have to do to get the answer here. But we can do this without actually doing any calculation on our own. I'm going to show you how you can create an expected frequency count from StatCrunch. And this is especially helpful if you had a vast probability distribution. So let's copy it in StatCrunch. All right, so I've got my values and my probabilities. So here's the way we can, in order for us to get the expected frequency count, we have to do a little bit of a cheaty thing. Here's what you can do. All right, so what we want to do is, let's just call var3, this is, I'll call it n. And what I'm going to do is put 722 in column 1, or in row 1, and I'll put some zeros. So this is just a way for me to say that I want to do 722 trials. This is a little bit of a workaround, but I'll show you what this gets for us. So I'm going to go to the stat menu and go to a goodness of fit test, chi-square test. What is observed is my n. I'm going to pretend that I got 722 times, but that doesn't even matter. All I'm getting is the expected frequency count. That's what I want. The expected are the probabilities in the pi. This is probability subscript I, pi. Those are what's expected, the expected relative frequencies. Click compute and you'll see what you get. So isn't that nice? So forget about this observed, that doesn't matter. What we have is these expected values for 1, 2, 3, and 4. So we can copy those right in.